Hello everyone. Thank you for having Group Learning, an ideal platform to learn and share knowledge across globe. Let's understand linear regression in more details today. We use linear regression in machine learning when we try to predict relationship between two variables. For example, let's say you have the transaction summary of your last year's sale and profit. And based on this, you would like to predict the expected sales and profit of this year. So this can be what is done through linear regression. Here you can see the line graph between sales and profit. The fitted straight line would estimate the expected profit based in the input sales. So here our machine learning algorithm must be sufficiently good to fit this straight line so that this passes through most of the data points. So before diving deep into linear regression coding, we need to understand few basic terminologies. The first one is correlation coefficient. Correlation coefficient is a measure of a linear relationship, linear correlation between two sets of data points. Its value ranges in between -1 to 1. A value of greater than 0 indicates that the two variables such as sales and profit are positively correlated, while negative values indicates a negative relationship. A value of 0 indicates that two variables cannot withdraw any relationship between each other. So let's understand this through these figures. In the first figure, as you can see, we have the perfect positive correlation, i.e., when the value at horizontal axis increases with the same proportion, the value at y is also increasing. The second figure has random plotted points and we cannot draw any inference out of it. So it has a zero correlation. While in the third figure, when values at y are decreasing, value at x is increasing. Thus, there is an inverse relationship between them. Therefore, it is negatively correlated. Now, let's talk about the p-value. In p-value, the p-value in statistics, the p-value is the probability of obtaining results at least as extreme as the observed result of a statistical hypothesis test, assuming that the null hypothesis is true. So what does this mean? It's quite confusing, right? So let's try to understand what does this mean in practical sense. Assume that you are doing a tossing experiment for 1,000 times where there can be either head or tail in the result, and you have the initial hypothesis of random assumption that number of head turns in the experiment equal to 994. So this is normally known as null hypothesis. How can we prove its basis? The answer is p-value. Let's consider if we receive the p-value as 0.0062, that means the coin has the probability of receiving tail only 0.006 multiplied by 1000 equal to 6 times. Should we reject the null hypothesis? or accepted. The decision is totally a business decision. If the business decision is such that the tails obtained should be within the range of 994 plus minus 6 as a threshold in the experiment, it has to be considered a valid range. Our null hypothesis is accepted and true in that case. Alright, so what is good fit or bad fit? So, a good fit is a measure of how well a linear regression model generalizes to a similar data. A good fit model produces more accurate outcomes. A good fit is a problem of fitting straight line in a best way that passes through most of the data points. As you can see in the first figure that the straight line passes through the middle of the most of the data points. So this is a good fit line. Thus, it has a good prediction accuracy over the badly fitted straight line as shown in this figure. A model that doesn't generalize well is a bad fit model. So let's talk about standard error. The standard error measures the accuracy with which a sample distribution represents a population. A standard error measures the accuracy with which a sample distribution represents a population. As you can see in this figure, the proportion of sample that would fall between 0, 1, or 2 or 3 standard deviations left or right can be defined as the sigma divided by square root of n. So this is what is known as standard error. And the last term, we are talking about the slope. The slope is also known as a gradient of a line. It describes the direction and the steepness of the line. Slope is identified by ratio of change in y-axis with respect to change in x-axis. We fit the straight line with our well-known straight line fitting formula, that is y equal to mx plus c, where m is the slope and c is the intercept. All good. Are you ready to go code? We will code into our subsequent next video. If you enjoyed this video, do like and share it. Also subscribe to our channel if you haven't yet, as we have a lot more exciting videos. Stay tuned and keep learning. Thank you.